Okay, Assalamualaikum and good day to everyone. We have come to the last topic on this chapter 9. Yeah, chapter 9 is on the characteristic, processing, and application of metals and alloys. And the last topic is about the metal matrix composite. Okay, what is a composite materials? Composite is defined as a two or more materials. Yeah, it can be phases or constituent integrated to form a new material. Okay, the constituent keep their properties, and the overall composite will have the properties different from the properties of each of the materials. The main advantages for composite is due to their high strength and stiffness to weight ratio because of the combination of two or more materials. Okay, in designing a composite materials, scientists and engineers have combined various metals, ceramic, and polymers in order to provide a new generation materials which improve the combination of mechanical characteristics. For example, it will improve the stiffness, the toughness, okay, uh, ambient strength, and also high temperature strength. Okay, composite composed of two phases. Yeah, one is the matrix phase, and we can call this matrix phase as a binder. Okay, this phase is continuous and surrounds the other phase. Okay, this other phase is actually the dispersed phase, which is the reinforcement phase. And this reinforcement phase is this continuous phase that is surrounded by the matrix phase, as what you can see in the illustration. Okay, the blue color is the matrix phase, and the cylinder-like particle is the dispersed phase. Is the reinforced phase that we add to the matrix phase. We add this dispersed phase to this matrix phase in order to improve the weakness of the matrix phase. Okay, here this is a picture taken using the scanning electron microscope (SEM). This is actually a picture of a cross-sectional area of a composite. Okay, where you can see this is a fiber or the reinforced phase, and it is surrounded by the continuous matrix. The black region is actually the matrix phase, and in between of this fiber and also the matrix, there is an interface. Okay. Okay, these are the types of reinforcing phase that we can add to the matrix phase. The reinforced can be in the form of short fiber. Okay, short fiber, and also it can be in the form of long fiber. Okay, the illustration shows to you is actually the picture of the composite. Eh? Composite, where you can see the fiber, okay, the long fiber is surrounded by the matrix space or embedded in a matrix space. Okay, and the reinforcement phase can also be in a particulate shape. Particulate shape is not irregular shape of particle of a flake. Okay, and also a flake, and it can also as a filler. The reinforcement phase can also act as a filler filler is just want to reduce the cost of a, material. We add filler to a material. Yeah, the objective of adding a filler to a material is just want to reduce the cost of the material. Yeah, reduce the cost of the product to reduce cost. Okay. Okay. What is the function of the matrix space? Okay. Matrix. We know that matrix has low density, low stiffness, and also low strength eh, than the reinforcing phase. Okay, so that we add the reinforcement to the matrix, yeah, and matrix plus reinforcement phase or fibers will produce high strength, high stiffness material. Yeah, matrix phase have several functions. The first one is to bind or holds the reinforcement. Okay, let me draw the composite. Okay, assume this is this is a material. Assume this is only a polymer material. Yeah, because of this polymer material has a low strength, low stiffness, so we add reinforcement to this polymer. Okay, so we add this fiber, this long fiber, which is the reinforcement. Okay, so this matrix space, yeah, will act as bind and holds the reinforcement. So the continuous space, yeah, surrounded this reinforcement is actually the matrix space, which will bind and hold this reinforcement. It will hold the reinforcement at that location, position. Okay, and it acts as a medium, eh? medium which by which an externally applied stress is transmitted, and distributed to the fiber. So if we give a tensile load, okay, to this composite, so this matrix will transfer the load to the reinforcement. Yeah, it works as a medium, to transfer the load to the reinforcement, and then to protect the individual fibers, from wearing, grinding, and rubbing, because the fibers is embedded in the continuous matrix space, and then build up the bulk of the composite and separate fibers, in order to prevent propagation of brittle cracks from fiber to fiber. So if there is a crack on one fiber, so matrix, this is matrix. This if there is a crack in one fiber, so this matrix will stop the crack propagation, so that it will cannot go to or cannot propagate to other fibers. Okay. What are the function of reinforcing phase? Yeah. What is the function of the reinforcing phase? Okay. One is to enhance the matrix properties. Yeah. This reinforcing phase. Okay. Reinforcing phase in composite. Okay, will enhance the properties of the material, will enhance the properties of the, for example, if we have polymer, yeah, at the beginning of process we have only polymer, so by adding this reinforcement, so it will improve, enhance the polymer or the matrix properties, and then to restrain, the movement of matrix phase and hold the fraction of the load. Yeah? So this fiber, okay, will restrain the movement of the phase, matrix phase. Okay, or it will stop the movement of the matrix phase and hold the fraction of the load along the fiber length. Okay, and then enhance the heat resistant and conduction, resistant of corrosion, and provide rigidity. And as a principle of load-bearing constituent, especially in a continuous fiber reinforced composite, because for this long fiber, it will carry, or it will hold the load along its length. Okay, in field composite, as a cheapener. In field composite, the reinforcement that we add to the matrix is actually as a cheapener in order to lower the cost of the materials. Okay, this is about the classification of composite. Types of composite is depends on its matrix phase. Okay, if you look at here, there are three types of composite. One is the matrix composite. The second one is the ceramic. And the third one is the polymer matrix composite. And the name of each of the composite types, it actually depends on the matrix. For example, you have a reinforcement. For example, a ceramic particle, silicon carbide. Yeah, you add this reinforcement to the matrix phase of a ceramic, to the ceramic. Yeah, so it becomes ceramic matrix composite. Yeah, you add the silicon carbide to the metals in order to improve the metals matrix. So it will become metal matrix composite. And same with if you when you add silicon carbide reinforcement to the polymers matrix, so it will become polymer matrix composite. Okay. Okay, let's look at this metal matrix composite, because we are in the chapter of metal. Okay, a composite material that has a metal or metal alloy, yeah, aluminum alloy, magnesium alloy, titanium alloy, copper alloy as the matrix base. Okay, it can be as a pure metal or metal alloy. It can be as a metric phase for metal metric composite. Okay, and the dispersed phase, the reinforcement can be in particulate. Okay, particulate, both continuous or discontinuous, continuous fibers and also short fibers, and viscous. Okay, viscous. That normally are stiffer, stronger, harder than the matrix. And normally the concentration is in the range of 10 and 16 volume percent. Okay, what are the continuous fibers that we can add to the metal matrix? Okay, the examples of continuous fibers are carbon, silicon carbide, boron, aluminum oxide, and refractory metals. And for this continuous reinforcement, there are silicon carbide whiskers, chopped fibers of aluminum oxide and carbon, and particulate of silicon carbide and aluminum oxide. So these are the option that you have to be added to the metal matrix composite. Okay, these are an example. These are example of metal matrix composite. The first one is continuous fiber reinforced metal matrix composite. Yeah, the fiber is boron and the matrix is aluminum alloy. Okay, this is from the side view. The circle here is referring to the boron fiber. It's actually, if you look at the 3D image of this composite, it's actually like this here. The picture taken from the side view of the composite. And this is the discontinuous fiber, yeah, viscous reinforced MMC. The viscous is titanium boron, reinforced titanium matrix composite. The discontinuous phase here is the titanium matrix composite, titanium matrix, and the reinforcement is the TIB. Okay, and here the another example is particulate reinforced MMC. Yeah, the reinforcement is the silicon carbide. Okay, where you can see the silicon carbide is in various shapes and also various sizes. Yeah, dispersed in this aluminum matrix. Yeah, the continuous phase is the aluminum matrix, and you can see various sizes, yeah, big size or and also small size of the silicon carbide, and some of them in a cluster, yeah. And also you can see some porosity in the composite, yeah, porosity, and also crack in the silicon carbide. Okay. Okay, MMC have been so intensely researched over the past years that many new high strength to weight materials have been produced. Mainly application of this MMC is in the aerospace industries and also automotive industries. It can be utilized at high service temperature. Okay, MMC have higher strength, greater stiffness, and better dimensional stability compared to the unreinforced metal alloy. Yeah, that's why we produce composite metal matrix composite. Okay, this is the classification of composite. Yeah? The classification of the metal matrix composite. The first column here is the list of fibers, and the second column is the list of matrix, and the third column here is actually the product or application of the composite. Yeah. Here, for example, if we have uh, graphite as the reinforcement, and we add with the aluminium as the matrix, yeah, the composite can be used, yeah, to produce a satellite. Yeah, the composite material is used to produce satellite, missile, and also helicopter structures. Okay, and if you have, for example, alumina as the reinforcement, and then you add with the aluminum alloy, yeah, okay, this composite can be used as the material for making superconductor restraints in fission power reactors. Okay, and here you can see some pictures on the MMC product. Okay, and here this is a brake disc and also a piston. Okay. Okay, this is about the mechanical properties of MMC. Yeah, you can see various types of MMC, yeah, according to the shape of the fibers. Yeah, particularly and no reinforcement. Only the what? Only the metal. Okay, and this is in the first column is about the tensile strength, elastic modulus, and strain to failure percent. Okay. Uh, for this continuous, yeah, the first one is about the continuous fiber MMC. Continuous fiber, long fiber. Yeah. And the example here, this is aluminium 2024-T6. Yeah. 2024-T6 in bracket 45% boron. Yeah, meaning that the reinforcement, this continuous fiber is boron. Yeah, the percent of the boron is 45%. Yeah, added to the metal matrix. Okay, and the metal matrix is aluminium, aluminium 2024 T6. Okay, 2024. Yeah. Yes, for your information, aluminum alloy. Yeah, there is a classification or designation of aluminum alloy. Yeah, from 1000 series to 9000 series. And for this aluminum alloy 2000 series, yeah, the major alloying element is actually copper. Yeah, the aluminum alloy series, yeah, it depend the number or the series is depend on the major alloying element in that alloy. Okay, for this 2000 series, the major alloying element is copper. And this T6 is actually the heat treatment process for this alloy. T6 meaning that this alloy has gone through heat treatment process at 1000 degrees C, meaning that this alloy has been heat treated 1000 degree Fahrenheit, sorry. Okay, and then for several hours, yeah, and then quench. Yeah, quenching meaning that rapid cooling in a bath, rapid cooling in a bath, and then we do aging, artificial aging. Yeah, artificial aging is a heating process, but at low temperature, reheating process. Okay, if you look at the properties, yeah, the continuous fiber composite have the highest have the highest tensile strength compared to the others. This is because of the this long or continuous fiber. This long continuous fiber can carry the load given to the composite along its length. Okay, so that's why the tensile strength is highest compared to others. Yeah, and here, for the alloy without any reinforcement, it shows the lowest tensile strength. Okay, okay, we have come to the end of this subtopic. Yeah, so as a summary for this chapter 9 on the metals alloys, you have learned about ferrous alloy. Yeah, you have learned about the classification of steels and also cast iron. And also you have learned about non-ferrous alloy. What are non-ferrous alloy? Non-ferrous alloys are alloys which do not consist any ferrum or iron. No iron, no ferrum. Okay, there are copper, aluminum, titanium, and magnesium alloy, refractory alloys, and nobles alloy. And also you have learned about heat treatment of metal. You have learned about annealing, tempering, quenching, spherodizing. So that's all about the heat treatment process. And you have also learned about the metal fabrication technique. Yeah, you have learned about the welding, casting, forging, rolling, and others. And the last one, you have learned about the metal matrix composite. Why we need to have this metal matrix composite in order to improve the properties of the metal alloy or metal pure metal. Okay, so thank you for listening to my lecture. I wish you all the best for this subject. Okay, bye. Assalamualaikum.